So what are we talking about today? We're going to write trig equations from their graphs. Right. Okay, before I start and do a whole lot, I'm going to highlight. And it's boxed for a reason, okay? So we're going to need this right here. Our answers today are going to be something like y equals 3 cosine blah, blah, blah. Or our answers are going to be something like y equals a 2 sine of blah, blah, blah. But we're going to make the equations, okay? So A is the amplitude, how high up it goes. Trig, and the reason I put trig is some of these graphs are going to be sine and some are going to be cosine. It depends on where you start, okay? Does that make sense? Believe it or not, the easier ones to make are the cosines because you can always find the maximum, right? It's not always easy to find the starting point unless it's right at 0, 0, okay? Now, we need to create it. So from its graph, first of all, A, which is the amplitude, is going to be the maximum minus the minimum divided by 2. It's just the average, okay? So if you need to find A, you look at the graph, you get the max, you got the min, you can find the amplitude. This minus this divided by 2. Okay, that'll get your amplitude, okay? Your B, your frequency, okay? 2 pi. Always 2 pi because we're going to do in sine and cosine. What's the period of sine and cosine? 2 pi, right? We looked at that yesterday on our notes, right? Sine and cosine is always 2 pi. So you take 2 pi and you divide it by the curve width. Whatever the width of the curve is will give you the frequency, okay? It's kind of backwards of what we did yesterday, right? Now the h is the horizontal shift, but it's always the opposite direction, right? We've done that. So if you go to the right, it'd be negative. If you go to the left, it's positive, right? It's always the opposite. And k is just your vertical phase shift, how much the graph has been moved up or down. Because we're going to take these and we're going to move them up and down, okay? So before we do anything, let's go back to what we did yesterday. But let's go and graph an easy one. And hopefully this is easy. So when I graph these again, I always start with two things, okay? The first thing I do is I want to find out what the graph looks like, because if I have no clue what a cosine graph looks like, then I don't even know where to start, right? So I take out my sheet, right? You guys pull out your sheet of your 6 graphs, and cosine, and I like to do it on the side, looks something like this. That's what a cosine graph looks like, okay? Now when I look at a cosine graph, I'm really looking at 4 important points. That's why I always do 4 boxes. Okay, I always do 4 boxes for a reason. It helps me, but there's 4 important points. There's a max. There's a min, right? There's the starting and the end, and then there's the x-intercepts, okay? So that becomes my 1, 2, 3, 4 parts, but it divides it into 4 sections, right? Which corresponds to my graph, okay? So this is the graph I need. I need to do a cosine. So then the next thing I do is I think about what's the period. This one's 0 to 2 pi. The standard one is. But to get the new period, I take 2 pi and I divide it by the b, right? Divide it by 2, okay? So I divide it by the frequency. So the new period of this one is pi. So what I'm going to do is fit this shape between 0 and pi. Does that make sense? Now I also know I'm going to go by pi halves, pi, 3 pi halves. I'm not going by thirds. I'm not going by thirds because there's no thirds in here, okay? So let's go ahead and put down the axes. Let's go pi halves. Let's go pi. Let's go 3 pi halves and 2 pi. Okay, how am I doing? Okay, so I'm going to go by pi halves, not thirds, because my period is just going to be pi. And I know I've got to have an amplitude of 3, so I've got to go up to 3, and of course to negative 3. Okay, now I'm ready to start putting the graph down. Once I have my axes in place, I know how wide it's going to be, I know how tall it's going to be. Let's fit this shape in here. Okay, so I'm going to use a pencil because I'm going to probably need to move it, right? So let's start off. I'm going to have this shape, it's upside down, 3, and at pi it's going to also be at negative 3 because I need this shape but upside down, right? I'm really using this one right here, right? Okay. Its halfway point is not down here, but it's up at pi halves, and it has x-intercepts here at pi fourths and at 3 pi fourths. So here's the first curve. Okay, it looks like that. Okay, we'll do it again because I want to get both curves in there. So same shape, but I'm just going to repeat the shape, and there it goes. Okay. All right. So far, so good. right? Not bad. We're getting better at these, I think. So that would be it if I didn't have to move it. I'm going to do a phase shift. It's what they call a phase shift. I'm just going to move it. So I have to move it pi force back, right? So I'm going to go pi force back because it's positive. So I'm going to go back pi force, and I'm going to go up 1. So pi force is 2 squares, because if that's pi halves, that's pi force, right? If that's pi halves, that's got to be pi force. So I'm going to move it back 2 squares and up 1. So every important point, the maxes, the mins, and the x-intercepts are going to go 1, 2, and 1. 1, 2, and 1. 1, 2, and 1. Pi force and 1. Back 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 pi force and 1. And here it is. This is my curve right there. Okay, that's not bad. I think you're getting better at these, right? Are you getting a little bit better at these?
Yes.
So there's my answer. And if I wanted to erase the pencil, I could. It doesn't hurt to have it in there, but you could say, well, I don't need that because that's not the answer. So maybe erase it. I don't know. You don't have to. Sometimes it helps to leave it, okay? Thumbs up on that one. Much easier than yesterday. You guys agree? All right, now, example 2. We have to make an equation. So here's what you do. Step 1. Here's always step 1. Is it a sine or is it a cosine? What do you think? Sure looks like a sine, doesn't it? I agree. I mean, you're going to hop on the roller coaster right there at 0, 0. You guys agree? You could call it a cosine, but then it gets more complicated. Let's call it the easiest. There are, ready? 4 different answers to this, and all 4 are correct. But let's pick the easiest, okay? You guys agree sine would be easiest, okay? So if we call it a sine, I'm going to start with y equals sine of something. Okay, let's just start there. Now the second thing I'm going to find, the 2, is I'm going to find the amplitude. Okay? To find the amplitude is max minus min divided by 2. Well, you can probably see it. Probably see the amplitude has got to be 1, 2, 3 degree 3. Everybody agree 3? So it would really be a is equal to 3 minus negative 3 divided by 2, but you can see it's 3. Everybody agree? You don't even need to do the formula because you see it goes up 3, right, and down 3, so 3 there, okay? Third thing I do is let's find b, which is the frequency, okay? So the way you find b is you take 2 pi divided by the width. Okay, by the width. Well, what's the width of this curve? One full ride, one full curve. I mean, you're going to go and take one roller coaster ride to right there. You guys see that? How wide is that curve? It's 4, right? So you take 2 pi and divide it by 4, and that reduces to pi halves. Okay? And I'm going to draw my parentheses. I might not need the parentheses, but I like to put my parentheses in there in case I need it. Now the next thing. 4. Has it been shifted?
Yeah.
Well, sine starts at 0, 0, right? This one hasn't been shifted at all, right? This graph starts right at 0, 0. It hasn't been shifted up or down. It hasn't been shifted back and forth. So I'm going to put in my x variable. I could put plus 0, but that would be kind of a silly thing to do. That is the equation. There's been no shift at all, right? You guys agree? That wasn't too bad. You guys agree? Not too hard? All right, let's look. You ready for example 3? Am I going too fast? Am I okay? So what do you think? What do you want to call this one? You want to call it a cosine? Okay. You could call it a cosine. You could even call it a negative cosine. Doesn't matter to me. You're gonna call it. Let's call it cosine. Okay. So if you call it a cosine, that means we're starting right there. You guys agree? You're gonna call it cosine. We're gonna start there because cosine starts at the top. So you find the top of the roller coaster and roll down. Okay. Now it does get shifted, right? So it's a shifted cosine. Let's call it a cosine. So let's go y equals cosine. Okay, let's just do y equals cosine. Now, what's the amplitude? Looks like 2 to me. Up 2, down 2. Everybody agree? Let's put a 2 here. To find b, we'll take 2 pi and divide it by the curve width. How wide is this curve? How wide? From here, take a full ride. So take yes. The full ride is all the way to here. You guys agree? One full ride, then you start again is to there. So 4 pi, right? So b is going to be 2 pi divided by 4 pi, which is 1/2, right? Draw your parentheses, okay? X variable, or theta. The book likes x. Now, your cosine got shifted, didn't it? Because normally it'd start on the x-axis, or the y-axis, but it got moved back, didn't it? How far did it get moved back? 2 pi. So it went back, right? So we're going to go x plus, right? Opposite 2 pi, right? Because you're going to go opposite. Make sure that's opposite. So it went back. And then it didn't get moved up or down. You guys agree? There's no vertical shifts, so we're done. The middle of the curve is right on the x-axis. The middle of the curve is right on the x-axis, okay? Let's flip the page and see if we can see them, okay? Flip the page. Oh, look at example 4, James. The middle of the curve is probably right up here somewhere, isn't it? It got bumped up, didn't it? The whole graph got moved up, didn't it? And we're going to find out how much, okay? So right off the bat, before we do anything, first, number 1, what do you want to call it? Y equals what? Okay? Do you want to call it a sine?
Yeah.
Okay, so you probably, are you going to start there? That's probably about right for a sine. I would have called it a cosine, but I think I can call it a sine. See, the thing is that exactly the middle? I think it is. I probably would have called it either a negative cosine or positive cosine, but let's call it a sine. Remember I told you guys there are 4 correct answers. There really are 4 correct answers. So let's call it a sine. I'll go along with that. So y equals a sine. What's my amplitude? I think it is 3, but if finding the amplitude is a little tough, we'll go, okay, max is 1, 2, 3, 4, 5, minus the min, which is negative 1 over 2.
3.
Which is 3, right? 6 over 2, which is 3. And you guys kind of thought it was 3, didn't you? Up 3, down 3, yeah. So you're right on the amplitude, okay? Okay, let's put a x variable and put a forgive me. I've got to find b. So b, 2 pi divided by, well, how wide is a curve? Looks like we're going to go from there to there, right? Let's count it. 1, 2, 3, 4, 5, 6, 7, 8. Or if we're a little, we can always count from here to here, right? Same thing. Or we can count from here to here, or I can go 1, 2, 3, 4, 5, 6, 7, 8. But I'm pretty sure it's 8 wide. You guys agree with that? So let's go 2 pi divided by 8, which is pi fourths. Sorry, it's sloppy. Pi fourths. Okay, you alright with that? It's 8 wide. Parentheses x. There we go. I was ahead of myself. Now it did get bumped, didn't it? It got bumped forward. How much did it get bumped forward? It got bumped forward. How much? 1. So we're going to pull it back. This is why it's opposite. So if we pull it back, we get an x minus 1, right? X minus 1. And it got bumped up. How much did it get bumped up? 2. Now if you're not sure, here's how you find k. Now k is the vertical. K is always going to be the minimum plus the amplitude, okay? So k is always going to be the minimum, which is a negative 1, plus the amplitude is 3, and you guys said 2, and you're right, it is 2, so plus 2. How am I doing? Thumbs up? It's a lot easier than yesterday's, right? You agree? Okay, example 5. So first of all, what do you want to call it? Okay, it could probably be a sine. I think a sine is actually a pretty good call because we're going to start right there. Okay, let's call it sine. Okay, because we're going to go up and down, up, right? I'd go along with the sine. I go y equals sine. Okay. What's the amplitude? What's the amplitude? Well, let's see. Max, the amplitude is max, which is 1, 2, 3, 4, 5, 6, 7, minus the min, which is 3 divided by 2. The amplitude. Amplitude's going to be 2. And you kind of can see it. It looks like it's up 2, down 2, doesn't it? The amplitude looks like it's up 2, down 2, doesn't it? Okay. So the amplitude is 2. Let's find b. 2 pi divided by the curve width. Okay, so these are pi fourths, right? So let me just find the curve width by doing it from here to here, okay? You ready? Let's do some counting. 1/4, 2/4, 3/4, 4/4. Want me to do that again? Okay, watch. These are fourths, right? I'm going to go 1/4, 2/4, 3/4, 4/4, right? So the width is 4/4 pi. 4/4 pi, or, yeah. So 4/4 pi's width, or pi, right? And what happens? What do you get for your b, or your frequency? 2. Now, before I go any further, I want to make one small little observation. If the scales are not in terms of pi, you'll get pi in your answer. If your scales are in terms of pi, you won't get a pi because the pi's canceled, right? That makes sense, right? So this is just going to be a 2. X, is there a horizontal shift? No, because sine likes to start right on the y-axis, and that's where we start. But it did get bumped up, right? So I'm just going to go ahead and draw, because I don't need a plus here, that'd be kind of silly. But how much did it get bumped up? 1, 2, 3, 4, 5. Do you see how it got bumped up 5? Now, if you're not sure to find, you can go, okay, well, it's the minimum, which is 3, plus the amplitude, which is 2, and plus 5. How's that? 1 thumb up, sideways, 2 thumbs up. Anybody? 2 thumbs up? All right. 2 thumbs sideways, James?